G'day, Michael here again. Just doing a short little vid here for the purpose of explaining why I've chosen the type of runners I've chosen, because I often need to explain the merits of everything that I do. I figured a video would be a lot easier than physically having to go through every time to explain it to people. Now, here's an instruction set for a very common soft closed drawer assembly, metal sides, etc. But if you're assembling the units yourself, you may find they are actually quite complex, although they are extremely well made. And you can see this. Don't be distracted by this cover. They produce nice. They produce them in white and stainless steel and probably a few other colours. But anyhow, you are restricted by, with any design, there's always some sort of advantage and disadvantage, and you are restricted with this design. You can see that there's a boxing on the side here. That is to facilitate the runner being mounted inside, but one of the restrictions that I find most annoying, or you may also find most annoying, is the heights are made up in increments. Maybe you'll have an add-on side, or depending on the height of the unit, you may have what's called gallery rails, which basically are a tube that extend between the drawer front and the drawer back to provide a stability of the drawer front, and this tube, this gallery rail, provides some adjustment so you can correct any discrepancies in the front and so forth. So it is kind of nice for the adjustment, and you will have seen in those different designs, in showrooms and so forth, you'll have seen these kinds of drawer runners operating, and you'll have seen this beautiful soft close mechanism. They roll very easily, and the soft close mechanism works very nicely. But any design has its pluses and minuses. That's one design restriction on this, is the height. They also use quite a bit of width, and they waste, with the runner and the box arrangement, they waste a little bit more height than these do, and so the volume available inside the drawer is reduced. Plus also if you don't have a height fairly fully used, you're unable to actually fill to the height of the drawer. With these runners, I'm able to make the box whatever size is required, and I'm pretty sure that most people find the assembly process and the adjustment process of these drawers a little bit more daunting than a box made out of 5 components and runners that get screwed on the side. So there is a simplicity factor to these runners as well for the lay person to assemble them. Okay, having said all that, I suppose I better move along to the design that I've chosen. Get these guys out of the road, I think. Probably the biggest advantage of these runners I've already bumped on, and that is I'm able to make the drawer the full height that's available in the space, a better width, but another item is the runners are available between 300mm and 700mm in depth, or that's about 1 foot to about 2'4" in the old currency. And I have, in this cabinet I've deliberately got 2 variants of that, and that is we've got a bottom mounting runner on the 2 lower drawers and a side mounting runner. You can see the drawer bottom showing through here. Side mounted runner on this top drawer. So you've got side by side. You can see this runner is basically underneath the drawer box, and this is beside the drawer box. So this is a side mounting drawer runner. It's got these tabs which actually will bear the weight of the drawer box, and that is held on with screwed on from around the side. Whereas the side mounting runners, which is what this is actually screwed through the runner component into the side of the drawer box. Now, you may have already spotted something, I'm not sure. Of course, I'm restricted to, or whoever's restricted to, the thickness of that side. So the screws have to be less than 16mm thick. Hence, you have a screw, something like that, little tacker. Alright, with the bottom mounted runners, you can use really potentially quite a long screw I choose to use 28mm because it's more than enough to do the job. Yeah, so we can use a better screw into the draw box from here. So the bottom mounted draw runners are far better structurally, but they do have the disadvantage is in here that they waste about 15mm of your potential height. Whereas here you can see the runner is actually, in this case, about a millimetre higher than the underside of the draw box. Okay, so there's the height, the width and the depth advantages to this draw runner type, which to me is all the reason to use these runners. But one attribute that I'm not that confident with other runner designs, although they are available, you can see here, this is actually a soft close drawer. The soft close mechanism in its own right, to me, introduces a whole lot of parts, which perhaps may be wrong, but over the longer term may prove to be a whole lot of components just adding to the mechanical complexity and therefore mechanical failure potential of the draw runner. So this is a side mounted draw runner with a soft close mechanism, whereas these ones do not have the soft close mechanism. Now the soft close mechanism, the energy that the mechanism uses to pull the drawer shut is actually energy that's been stored from when you opened the drawer. So you've provided the energy in loading the springs by opening the drawer that it uses to pull shut. Now these drawers operate at exactly the speed you operate them, so you can open them and shut them as you wish. Like let's say you're working on the kitchen counter, doing whatever you're doing. You can quickly use the drawers. Open a drawer, close it again, grab another drawer, open and shut at exactly your speed. Whereas with the soft close mechanisms, you have to wait for the drawer to close itself before it's out of the road for you to grab the next drawer. So, not that I think it's a big deal, but you could find it irritating. Whereas these drawers perform, as naturally they would to whatever force you're putting on them. These drawers do not clack shut, which may be a fear in some people's minds. They may have had drawer runner assemblies where there's a bit of a some of the older designers had like a gradient section on the drawer runner, which used some of the weight of the drawer to kind of pull the drawer shut, and so they would sort of clack into a closed position. Whereas these actually don't have that; they just simply operate horizontally. Okay, I don't know whether it shows up very well in this video, but you can see these. I'll pop this runner out. You can see these bearing cages here. There's a number of ball bearings, so it's quite a robust design. As you put the drawer runner components together, what ends up happening is that bearing cage is not correctly aligned. So, well, in this case, the soft closes, well, you can see that hasn't parked properly. What's happened is the bearing assembly has hit a stop internally, and you need to overcome that position error by actually sliding this part over the bearings, so it's not rolling, it's actually just grinding past them to park it the first time. That aligns the bearings. So that's a bit more visible here. So I'll take that one out. So let's push that in place. The runner assembly, going nicely. There's a stopper here. The bearing cage has hit that stopper, but the drawer is not closed. So you have to push past that point until it's in the closed position. Now the bearing assembly is all aligned, so the drawer runs correctly. So I'll show you how the drawer comes out of the cabinet. There is a tab here which may or may not be clearly visible. I might do a bit of a blow up on that. Give me a sec. Come on, autofocus. Do you think? There we go. Alright. So it's a matter of lifting this tab up, and there's the same kind of tab on the other side, and it's basically put on the other side of the drawer as if it was turned over. So on the left hand side the tab gets pushed up, on the right hand side the tab is on the top side and has to be pushed down. Okay, so that tab I demonstrated earlier, on the left hand side it goes up. The drawer runner components, you can imagine they actually use the same component on the left hand side of the drawer as they do on the right hand side, so it's basically turned over. The left hand side, the tab needs to be lifted up, and on the right hand side, push down, pull the drawer out. On the bottom mounted drawer runners, the drawer runner component is protruding past the underside of the drawer box, and so this surface, which is greased for the ball bearing assembly, can pick up a lot of grit and fluff and whatever if you carelessly put them on the floor or, you know, typical building site dust and grime. It's very destructive for the drawer runner. The side mounted runners, being a little bit up from the bottom, don't suffer from that problem. But in any case, it's good to keep these bearings away from dirt and grit and fluff and, you know, whatever. Okay, so I'll push these all back together again, insert the drawer. There's that black plastic component. If you've got the drawer runners in your possession, the black plastic component helps you align the drawer. Bearing cage comes to a stop, like I demonstrated with the loose piece. So the drawer is now, there's quite a lot of friction there. You need to overcome that friction to push this drawer runner component that's on the drawer into correct alignment on the bearing cage. Now it's aligned, the drawer will open and shut nicely. These drawers perform much better with a load on them. Now I guess this is about, I don't know, 6 or 7 kilos or something, I don't know the weight, which is probably, I don't know, about 14 pounds or something. But as soon as they have a weight in them, they actually perform much more smoothly. With this drawer runner design, the opening and shutting is as fast as you operate it. They're not restricted by a soft close mechanism requiring a certain amount of time to close. You may or may not find this annoying, but many people would find it annoying if they're trying to quickly jostle through the drawers. The slower mechanism can be a bit annoying. Alright, so that's the two different designs and the merits of the bottom mount versus the side mount. The soft close versus the non-soft close, and that's just the variations within this format. I tend to prefer buying the bottom mounted runners, but the bottom mounted drawer runners of course cost the space. The side mount is a little bit weaker in the way it's mounted. So everything's got a plus and a minus, but there you have it. The process of mounting these drawer runners on the side of the box is most easily done with using a marking gauge, which is a device like this, which has got a spur on it with a guide surface, set at 24 millimeters. That's just a bit under an inch. And a line scored on the side of the drawer to give you a centre line for those drawer runner components. And then you end up with that drawer bottom protruding below the runner. Just nicely. Okay, that's it. If you find the videos that I've prepared interesting and you're interested in seeing some more, please by all means press the subscribe button. I can't think of anything else to add here. That's just about all spoken about. Yeah, bye for now.